Finishing up 5.4 today with something called the remainder theorem. The remainder theorem is a quick and easy way to find the answer to a polynomial on division, right? So basically what it says is the remainder is the answer. So like here we have p of x equals x cubed plus 4x squared minus 8x minus 6. And you want to find p of 3. Well, if we were doing what we would have known up until this point, we'd have taken 3 and substituted it in. We'd have gone p of 3 equals, we would have gone 3 cubed plus 4 times 3 squared minus 8 times 3 minus 6. Broken it down, put it in our calculator, figured out somehow that the answer is 33. Well, this remainder theorem, actually, you can use synthetic division to get that same answer. So if you take whatever number it is that you want to substitute that in, put it in your penalty box, start your synthetic division like normal. So you have 1x cubed, 4x squared, negative 8x's, and negative 6 constants. When you get down here, your remainder will be this same value here. Your remainder is your solution. So if we drop our 3, 3 times 3 is 9. 4 plus 9 is... Wait, what did I just do? Why did I write that? Rewind. Beep. Drop the 1. I'm just making sure you're paying attention. So 3 times 1 is 3. 4 plus 3 is 7. 3 times 7 is 21. Negative 8 plus 21 is 13. 3 times 13 is 39. Negative 6 plus 39 is 33. That's the remainder spot. Your remainder is your solution. So P of 3, when you substitute in 3, you would get out 33. And you can use synthetic division to find that also. So like on this one, instead of taking 1/2 and plugging it in for every single x and simplifying it, I can use synthetic division. So if I want to find the answer to 1/2, 1/2 goes in the penalty box. I've got 2x cubed, negative 1x squared, 10x's, 5 constants. Skip a line, draw a line, drop your first number, this time 2. So then we go, half of 2 is 1, negative 1 plus 1 is 0. 1/2 times 0 is 0, plus 10 is 10. 10 times 1/2 is 5, 5 plus 5 is 10. Your remainder is your solution, so P of 1/2 equals 10. Another one, find P of 3. So we want to substitute in 3. So 3 goes in the penalty box. We've got 1x to the 5th. Don't forget, we have 0x to the 4th. If there's a term that does not happen, you have to represent that with a 0. Negative 2x cubed, negative 1x squared, 0 x's, and 2 constants. Skip a line, draw a line, drop the 1. 3 times 1 is 3, plus 0 is 3. 3 times 3 is 9, plus negative 2 is 7. 7 times 3 is 21, plus negative 1 is 20. 3 times 20 is 60, plus 0 is 60. 3 times 60 is 180, plus 2 is 182. So P of 3 equals 182. All right, one more example. We want to find P of negative 2. So negative 2 is in the penalty box. We've got 1x cubed, 7x squared, 4x's. We have no constants. We have to represent that constant that is not there with a 0 also. That's a common mistake to forget that 0 on the end when there's no constant. So I drop down the 1 times negative 2 is negative 2, plus 7 is 5. Times negative 2 is negative 10, plus 4 is negative 6. Times negative 2 is 12, plus 0 is 12. There's my answer. So P of negative 2 equals 12. That is how you can use synthetic division to use the remainder theorem to find values of a polynomial.